What if, somewhere out there, in the silent dark between the stars, something is moving, not drifting, but acting? You see, comets and asteroids have always been our messengers, fragments of ancient time that fall into our field of view for a moment and then vanish again. We name them, we track them, we map their paths. But every so often, one arrives that refuses to behave. First, it was Oumuamua, that strange, cigar-shaped visitor that sped through the solar system without a tail. Then came 2I Borisov, a more familiar icy traveler. And now, 3I Atlas, on paper, just another interstellar object, but in reality, perhaps not. When it reached its perihelion, that closest point to the Sun, something extraordinary happened. Its brightness surged by 22%, and a cluster of 10 smaller bodies appeared, holding formation with uncanny precision. A signal was detected, faint but distinct, right at 1,420 MHz, the hydrogen line, the universal frequency that every astronomer knows to listen for. And then, silence. The data streams went dark, as if the sky itself had turned away. Now, I suppose one could say it's all coincidence, a trick of plasma, a noise in the detectors. Yet, if the universe has always followed its own quiet logic, what do we do when that logic begins to twist? When something or someone seems to move within it? Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple, to help you drift off to sleep while exploring the wonders of science. Where are you on the map? Let me know where you are in the world and what time it is in the comments. It's always fascinating to see who's joining us from all around the world. So let's continue. When we first turned our instruments toward 3I Atlas, there was no reason to suspect that it would be anything other than another faint blur among the endless stars. The interstellar visitors that had come before Oumuamua and 2I Borisov had already reminded us that the solar system is not a closed garden. Space, after all, breathes. It exchanges material, it trades in dust and rock and ice across unimaginable distances. But 3I Atlas, well, it seemed to breathe differently. Its motion through the void had a calmness to it, a stability that felt, somehow, deliberate. You see, when a comet approaches the Sun, it should become restless. Ice sublimates, jets erupt, the nucleus tumbles chaotically as sunlight scorches its surface. Every fragment of rock and frozen gas fights to escape, and so the object begins to spin, wobble, fracture. It's a beautiful kind of disorder, the physics of heat meeting ancient cold. Yet, as the data came in from the first telescopes tracking 3I Atlas, that disorder never arrived. Its hyperbolic orbit, steep and precise, showed none of the usual deviations. The object held its course with almost mechanical calm, no visible tail, no jets, no rotation that our proof-glass instruments could measure. And then something else happened. One night, a team at the Pan-STARRS Observatory noticed faint points of light, accompanying it not debris, not random flares of reflection, but distinct companions, moving in perfect synchrony. 9 smaller objects, each maintaining an exact distance from the main body, traveling together like a formation of satellites around a silent command vessel. That alone would have been astonishing. But their arrangement, when analyzed, revealed a geometry so precise that even the most skeptical researchers paused. I remember reading the first report late at night, the room dim, except for the glow of the monitor. 9 subordinate objects in formation, it said, maintaining velocity and trajectory within error margins too small to attribute to chance. That line lingered with me. Too small to attribute to chance. In astronomy, we're used to working with probabilities, to living with error bars and statistical noise. But here was something that seemed to resist the very idea of randomness. What's interesting is that multiple observatories confirmed it almost simultaneously from Chile, from Hawaii, from the Canary Islands. The light curves matched, the spacing matched. Even the subtle variations in brightness appeared to oscillate together, as if some hidden metronome were guiding them. And the more we looked, the stranger it became. If they were fragments, we would expect chaos, collisions, diverging paths, tiny changes in angular momentum that would, over hours or days, scatter the pieces across the sky. But the cluster around 3I Atlas remained ordered. It didn't even rotate as a group, as gravitationally bound objects often do. It simply glided. Astronomers tried to model it, of course. They simulated the gravitational field, they included outgassing effects, they accounted for every plausible form of radiation pressure. Nothing fit. There was no natural explanation that could preserve that arrangement so close to the Sun, where tidal forces tear even strong materials apart. Some proposed that perhaps we were seeing a perspective illusion, that the 9 companions were not in formation at all, but simply aligned by chance along our line of sight. But as the days passed and the angle of observation changed, the formation persisted. It adapted its projection perfectly, like something aware of being watched. You know, there's a quiet discomfort that creeps into science when nature begins to look intentional. We are trained to distrust our instincts, to resist the seductive idea that the cosmos might contain agency. Yet, sometimes the data refuses to be polite, and that's what 3I Atlas did. It refused to behave like a comet, like an asteroid, like anything that fits neatly into the familiar catalogue of celestial bodies. There was one particular night, I recall, when a European team detected a brief surge in brightness, about 22%, sustained for only a few seconds. That kind of increase would normally suggest a burst of volatile material. But again, no trace of dust, no spectral evidence of gas. Just light, clean and sharp, as though the object had briefly turned a mirror toward us. And then, as quickly as it appeared, it was gone. That was the moment the whispers began. Among scientists, whispers take the form of careful phrasing in private correspondence, non-random distribution, possible engineered configuration, photonic response inconsistent with thermal model. They never say the word aloud, but you can feel it, lingering between the lines, the word control. Well, I suppose one could argue for some unrecognized natural mechanism, perhaps electromagnetic interactions or a resonance effect within the solar wind, perhaps. But the precision was unnerving. The distances between the objects were constant to within a fraction of a percent. Their collective motion matched the central object's velocity vector exactly. It was as though they were pieces of a single system, each fulfilling a role. And yet, every attempt to detect a connecting structure, a dust bridge, a halo of shared material failed. They were separate but coordinated, independent but unified. If it had been a spacecraft, it would have been a formation maneuver of extraordinary sophistication. But that's the thing, there was no evidence of propulsion, no ion trails, no jets, no thrust signatures at all. Some began to call it the choir, 10 voices in harmony, singing through the void. Others dismissed it as poetic nonsense. But to me, that description carried something true. There was a rhythm to the data, a pattern of brightness variations repeating every 7 minutes and 49 seconds across all observed points, as if the entire system were pulsing in time, sharing a heartbeat that no natural model could replicate. We tried to ignore the unease, to remain grounded in the mathematics. But there was a feeling that this was the beginning of something, that the solar system had become a stage for an event we did not yet understand. It's humbling, really, to realize how fragile our certainty can be. For centuries, we have built models of celestial mechanics that describe the heavens with exquisite accuracy. And yet, with one strange visitor, that foundation begins to tremble. In the days before its approach to perihelion, the object maintained its steady pace. Telescopes all over the world watched as the cluster closed in toward the Sun, each point maintaining its spacing despite the increasing solar radiation. By then, even the most cautious institutions had joined the observation campaign. The European Space Agency, NASA, the Chinese National Observatory, all sharing data, all watching. But under the surface, there was a kind of tension, an unspoken anxiety that perhaps what we were seeing could not be easily explained, or worse, could not to be explained at all. You might imagine that scientists would be thrilled by such an anomaly, but the truth is more complex. Science thrives on order, on predictability. When the cosmos plays by our rules, we feel at home in it, but when it begins to act out of tune, we find ourselves small again, uncertain, standing at the edge of knowledge, looking into the dark. I remember an astronomer from the Jodrell Bank Observatory saying quietly during a live stream, "If this isn't natural, then we are witnessing a conversation we're not invited to." It was half a joke, but not entirely. Because that's how it felt, as though three Ayatlas were moving with purpose, carrying out a script written beyond our comprehension. Perhaps it's arrogance to think that we'd recognize intelligence if we saw it. We tend to imagine machines, signals, words, symmetry, things that look like our own creations. But what if intelligence could hide in motion itself, in the geometry of trajectories, in the choreography of light? What if we've been watching messages pass through the solar system for centuries but never learned the language? And as three Ayatlas approached the sun, the light from it began to waver. Not from physical obstruction, but from interference, the sun's radiation playing havoc with our detectors. Soon it would pass behind that blinding glare, entering what astronomers call the solar conjunction blackout, a period when communication and observation are impossible. Normally, we'd expect that silence. But this time, the timing felt deliberate. The blackout would coincide perfectly with the peak of its brightness, and with the moment when the formation reached its closest alignment. Before that silence arrived, we had one last clear transmission of data, the brightness still stable, the formation intact. And then, almost as though on cue, the instruments began to saturate. The signals fell away. The object and its companions disappeared behind the Sunday, and that's where things began to unravel. Because when something crosses into that region, we expect to lose sight of it for a time. But what we don't expect is what followed: the faint detection of a narrowband signal at exactly 1,420 megahertz, the hydrogen line, the cosmic frequency of communication. It was brief, almost ghost-like, but it was there. And then, once again, silence. So now, as the world's observatories wait for it to emerge from the sun's glare, we find ourselves holding our breath. If it reappears as expected, the story may settle back into the realm of physics. But if it doesn't, if it comes out of that brightness, altered, displaced, or not at all, then perhaps the idea of natural will need to be rewritten. And that's where we must go next, into the shadowed side of the sun, into that strange period the astronomers call the blackout, where signals die and mysteries grow louder in the silence. When three Ayatlas slipped behind the sun, it felt as though the sky itself had taken a breath. Telescopes fell silent, data streams halted, and what had been a global conversation among observatories dissolved into the waiting hush that follows mystery. Astronomers call it the solar conjunction blackout, a period when any object near the sun becomes invisible, its light drowned in the glare, its signals lost in the violent storm of radiation and magnetic noise. It's a perfectly ordinary thing, usually. Spacecraft vanish into that brilliance all the time, and we wait, patiently, for them to emerge again. But this time, patience was laced with unease. Because for three Ayatlas, the blackout came at the most improbable moment, precisely when the object's brightness had peaked, when the formation of 10 bodies had drawn itself into its most symmetrical alignment. You see, in science, timing matters. Coincidence can often be explained, but when the cosmos seems to choose its moments with precision, we can't help but wonder. As the last frames came in before the loss of visibility, the object and its companions glowed with a peculiar steadiness, brighter than any natural body so close to the sun had a right to be. And then, as though a curtain had been drawn, they were gone. Normally, during a blackout, data simply ceases. The sun's interference is a storm of plasma and electromagnetic noise that makes even the most sensitive instruments useless. Yet within hours of the disappearance, something strange occurred. A handful of observatories, monitoring radio frequencies, detected an unusual spike, a short, clean signal, centered near 1,420 megahertz, the hydrogen line. It was faint, almost buried in static, but unmistakably structured. Some dismissed it as solar interference, others hesitated to speak at all. The coincidence was too sharp. The one frequency every astronomer recognizes, the one we use as a cosmic common ground, had come alive, just as three Ayatlas slipped from view. And so began the long days of silence. Across the world, observatories waited for the object to reappear on the far side of the Sunday. But in the meantime, the blackout took on a different kind of weight. It was no longer just a gap in observation. It became a question suspended in time, a pause filled with speculation, rumor, and quiet fear. In those weeks, I spent many nights looking at the empty coordinates where 3i Atlas should have been. There's something deeply unsettling about watching nothing. You know where the object is, you know it must be there, but the sun stands between you and it a wall of brilliance that conceals everything. I found myself wondering what might be happening in that hidden space. Was the formation still intact? Was it disintegrating, as so many comets do under the sun's relentless heat? Or was something else unfolding, unseen, in that furnace of plasma? Scientists tried to fill the silence with models. Some proposed that the surge in brightness before the blackout had been a natural flare, the release of trapped volatiles within the object's crust. Others pointed out that the geometry of the event, the perfect symmetry, the timing of the signal, made that explanation unsatisfying. And then there were those who began to whisper the unspoken hypothesis that the blackout was being used deliberately, that the sun's glare had provided the perfect cover for a maneuver. You know, that's the curious thing about human nature. When faced with the unknown, we oscillate between humility and paranoia. We want to believe that the universe is orderly, that every effect has a cause within the realm of nature, but we are also storytellers, wired to sense intention in patterns. The more improbable the alignment, the more our minds turn toward purpose. I remember a conversation with a colleague during those days of waiting. We sat in a quiet observatory room, the screens filled with blank solar maps. He said, "If, and it changes course behind the sun, we'll never see it happen. That's the perfect place to hide." He meant it half as a joke, but the thought lingered. Behind that blinding sphere, anything could occur: acceleration, deceleration, even division into multiple trajectories, and when it emerged again, we'd have no way to prove what had taken place in the dark. Meanwhile, small anomalies began to surface in the data from solar probes. Instruments, designed to monitor solar wind fluctuations, picked up faint, rhythmic modulations in plasma density, almost like pulses, repeating every few minutes. The patterns didn't match any known solar process. They were subtle enough to dismiss, but once noticed, impossible to ignore. Some scientists speculated that the pulses might correspond to the 7-minute and 49-second rhythm previously observed in 3i Atlas's brightness variations. Others called it coincidence. But the alignment was precise, too precise. Then came the silence from official channels. At first, agencies like NASA and the European Space Agency released the usual updates, routine reports about the conjunction and data interruptions. But as days passed, the tone shifted. Statements became shorter, vaguer. Public data archives were quietly delayed. And for those of us who follow the movement of information as closely as the movement of stars, that delay spoke volumes. It's not that something was necessarily being hidden. It's that the uncertainty itself had become too great to manage publicly. In online forums, amateur astronomers debated endlessly. Some claimed to have captured faint reflections, fleeting glimmers in coronagraph data. Others insisted that the object had fragmented entirely. The truth, however, was simpler and stranger. We didn't know. For the first time since we'd begun watching the skies with modern precision, a celestial body of such interest had slipped into a silence so complete that even the instruments designed to pierce the sun's halo could find nothing. And so the story became one of absence. Every night, the world turned beneath a sun that was hiding something. Every morning, observatories recalibrated, searching for whispers in the noise. Some compared it to listening for a heartbeat beneath the roar of a waterfall. Occasionally, a fluctuation would appear in the data, a ripple, a spike, a momentary asymmetry, and for a few hours, the scientific community would ignite with hope. But each time, it faded, absorbed into the vast indifference of solar radiation. Still, a few of us couldn't shake the feeling that the blackout was part of the phenomenon itself, not just an obstacle to it. Imagine for a moment that you wanted to move unseen within the solar system. The sun, with all its blinding fury, would be your perfect veil. Behind that brilliance, light curves flatten, radar loses coherence, radio signals are drowned in noise. It's a region where, Observation fails a cloak woven from light itself. What if 3I Atlas knew that? What if, whatever it was, it had chosen its approach so that its perihelion would coincide exactly with the period when human eyes could not follow? The thought is almost too theatrical, too human. And yet, the timing, the geometry, the signal, all these things whispered of choreography. As the blackout stretched into weeks, the scientific community divided. One camp insisted on patience. The object would reappear, as all comets do, perhaps altered, but still natural. The other camp, quieter, cautious, sometimes meeting in private, began to explore models that no longer excluded intention. They considered controlled motion under radiation pressure, photon sails, active stabilization using electromagnetic fields. Each hypothesis led further from comfort and closer to the edge of what we are willing to call possible. I remember the mood shifting around that time. Press releases became hesitant, phrased with an odd mixture of reassurance and uncertainty. "We expect to reacquire the target soon," they said. The lack of data is consistent with solar interference. But between the lines, you could sense something else, a reluctance to promise that the object would indeed return to view. And then there was the matter of the missing signals. During a normal solar conjunction, spacecraft on the far side of the Sun sometimes manage to transmit through brief windows of low interference. We catch fragments of telemetry, flickers of data bouncing around the Sun's magnetic field. This time, even those background patterns were quieter than expected. It was as though the region around the conjunction had gone, still a silence that extended beyond simple obstruction, almost as if something were absorbing the noise itself. In the weeks that followed, public interest surged. The press demanded answers, and agencies responded with polished calm. But among the scientists, conversations grew restless. The data was being shared less freely. Some observatories reported that access to certain telemetry channels had been restricted, citing technical maintenance. Perhaps it was coincidence, perhaps not. In the absence of clarity, speculation becomes its own gravity well. And all the while, the Sun continued its ceaseless burning, indifferent to the drama unfolding around it. For me, the most haunting image from that time wasn't any photograph or dataset, but a simple simulation of 3I Atlas passing through perihelion. A tiny cluster of points swallowed by a sphere of fire, vanishing for a few days, then emerging again into the cold. Watching that animation, I couldn't shake the thought that we were looking at a curtain of transformation, that whatever went in might not be what would come out. You know, the blackout became a metaphor of sorts. Not just a physical barrier, but a symbol of how knowledge itself can vanish behind its own brightness. We build our instruments, we stretch our vision, we illuminate the dark. But sometimes the light blinds us. Sometimes we have to admit that the universe has corners we cannot reach, and that perhaps it chooses when to show itself. As the final days of the blackout approached, every observatory on Earth turned toward the region where 3I Atlas was expected to emerge. We waited for the first glimpse, the first hint of motion on the other side of the Sunday, and then, almost imperceptibly, the noise began to change. A faint modulation appeared again near 1,420 MHz, followed by a distant flicker in the optical range, not bright, not yet clear, but there. And in that moment, every theory, every fear, every hope collapsed into a single truth. It was returning, but what would return was no longer certain. The formation, the geometry, the silence, all of it hinted that something had shifted during those hidden weeks, and as the instruments began to wake, once more, as the sun's glare slowly loosened its hold, we prepared ourselves to see what would emerge into the light. That, I suppose, is where the story truly begins to change, when the darkness gives something back, and we must decide whether what we are looking at is still a comet or something entirely new, moving with intention through the solar wind. The first signal came quietly, almost buried in the static. At first, no one was certain it was even real. A narrowband pulse at precisely 1,420 MHz, the hydrogen line, the frequency that every radio astronomer on Earth recognizes instinctively, almost like a reflex. It's the cosmic standard, the universal channel through which we've always hoped a message might come. And now, of all times, it was whispering back. You see, when an object re-emerges from behind the sun, it usually returns to us in a predictable way. The instruments warm up, the sensors catch a faint glimmer, and the data begins to flow again, steady and unremarkable. But when 3I Atlas came out of the solar glare, the readings were anything but ordinary. The first optical detections showed a renewed brightness, not fading from the solar heat as comets always do, but intensifying, its luminosity pulsing in short, sharp intervals. The increase was measurable, precise, 22% higher than before it had vanished. That number may sound arbitrary, but to those of us watching, it was chilling in its clarity. Brightness does not change like that without reason. No dust tails, no outgassing, no signature of debris. The object's surface seemed to reflect light in a way that defied thermodynamics, as if it were responding to the sun rather than reacting to it. And the pattern of light pulses, when analyzed, aligned perfectly with the frequency of the radio signal. Two phenomena, one visible, one invisible, moving in rhythm. For a moment, science lost its words. Some said it was plasma interference, a trick of solar radiation scattering against the object's magnetic field. Others proposed some rare electromagnetic phenomenon within the heliosphere. But none of those explanations could account for the precision of the timing, nor the uncanny consistency between the optical and radio events. Every pulse in brightness mirrored a microburst at 1,420 MHz. Every burst matched the same 7-minute and 49-second cycle observed before the blackout. Whatever 3I Atlas was doing, it was continuing. Well, perhaps it's only natural to resist the idea that something could choose to emit at that frequency. After all, 1420 MHz is not just any number. It's the fundamental resonance of neutral hydrogen, the most abundant element in the universe, the frequency chosen by SETI programs for decades as the most logical channel for interstellar communication. Hydrogen is everywhere, the simplest atom, the building block of everything. To speak at its frequency is to speak the language of the cosmos itself. And that's what made it so unsettling. Because if this was noise, it was the most articulate noise the universe had ever made. Teams across the world scrambled to confirm it. In South Africa, the Meerkat array detected the same signal pattern. In California, the Allen Telescope array verified its recurrence, faint but clear, each pulse falling exactly on schedule. Even smaller observatories, amateur setups that had tuned into the frequency range, began reporting it. The signal was omnidirectional, not localized, as though the entire region of space around 3I Atlas was resonating at that single tone. I remember one researcher saying softly during a conference call, "It's as if it's saying hello in the only frequency we all agree to listen to." No one laughed. The words hung there, uncomfortably true. But science, as ever, must be careful. Extraordinary claims require extraordinary evidence. The hydrogen line is also the noisiest part of the radio spectrum, filled with emissions from galaxies, nebulae, and the cosmic background itself. It's easy to imagine structure where there is only coincidence. And yet, coincidence doesn't synchronize with optical pulses. It doesn't appear and vanish with perihelion. It doesn't move with precision, keeping tempo like an unseen metronome, marking the seconds of some vast and deliberate rhythm. What caught my attention most, though, was not the signal's existence, but its silence in between. Each burst at 1,420 MHz was sharp, clean, and then utterly gone, leaving no fading tail, no echo, no dispersion, as if the source were switching on and off with mechanical accuracy. That absence, the deliberate restraint of it, felt almost intelligent. And that's the thing, you see. Nature loves gradients, transitions, fuzziness. Machines love edges. In the following nights, as the object moved away from the sun's glare, its light steadied but did not dim. High-resolution spectroscopy revealed no trace of molecular emissions, no carbon, no hydroxyl, no water vapor. It was as if it were made of something not meant to sublimate, something that refused to behave like rock or ice. One scientist described it as optically alive, another called it a mirror that chooses when to shine. Perhaps, I thought, the simplest explanation is still the best, that we're seeing an interaction of solar plasma and magnetic fields. But the models wouldn't fit. To produce that kind of structured emission, the magnetic topology would have to oscillate with near-perfect periodicity, synchronized across millions of kilometers of solar space. And even then, the signal's bandwidth was too narrow. It wasn't noise, it was a tone. Meanwhile, a few independent researchers began to explore another hypothesis, one that many dismissed as too bold, even reckless. What if 3I Atlas wasn't just reflecting or resonating, but transmitting? Not information, in the way we understand it, not words, not data, but intention, the way a pulsar transmits time, the way a heartbeat transmits life. I suppose we've always imagined that if we were to encounter something truly alien, it would announce itself through complexity, an encoded message, a pattern of primes, a mathematical key. But maybe we've misunderstood. Maybe the first language of the universe isn't complexity but simplicity. A single frequency, a single pulse, a single rhythm, repeated through light and radio alike. If that's true, then the message was not in the data, but in the choice itself, the decision to use the hydrogen line, to emit only when visible, to speak only when hidden behind the sundae. The more we studied it, the more peculiar the sequence became. The intensity of the pulses was not constant. There was a subtle modulation, as if the signal were being shaped. Plotting that modulation revealed an almost harmonic pattern, 3 rising peaks, followed by 1 sharp drop, repeating endlessly. It resembled the spectrogram of a coded beacon, but with no discernible information. It was, in its own way, beautiful. As the weeks passed, the debate within the scientific community deepened. The conservative voices held firm. It must be plasma interference. The hydrogen line emission could be explained, they said, by resonance effects in ionized hydrogen near the object's surface. But when confronted with the rhythmic synchronization to the optical pulses, their equations faltered. Others proposed that the signal was being amplified, not generated, that the object was acting as a lens, focusing cosmic background radiation into coherent bursts. Yet no known material could reflect and shape such frequencies so precisely. What fascinated me most was that amid all the confusion, no one could deny the order. There was structure, purpose perhaps. A choreography unfolding in both light and sound. During one observation session, as the signal flared again, a colleague turned to me and whispered, "What if it's testing us, just seeing if we notice?" It was said half in jest, but the thought lodged itself deep in my mind. Because that's what it felt like, as if the universe had dropped a pebble into the pond, and we were watching the ripples, wondering who threw it. In the nights that followed, I began to think more philosophically about it. Maybe the cosmos is full of these quiet gestures, events that hover on the edge between physics and intention. We are simply too young to recognize their grammar. After all, a moth sees fire as nature, not message. Maybe we too are looking at something meant to be understood by another kind of mind. The official reports, of course, remained careful. Transient emission event, they called it. Correlated optical and radio anomalies. But privately, the tone was different. Observatories began cross-checking the 1,420 MHz data against older records, searching for similar bursts. Some found faint matches, brief events buried in solar noise, stretching back years. It raised a haunting possibility that 3I Atlas wasn't the first to speak, only the first we were ready to hear. And that's how the question began to shift. We stopped asking what the object was, and started asking what it was doing. Because if the hydrogen line was a kind of cosmic handshake, then perhaps this was not a beginning at all, but a continuation of a conversation that has been echoing through time, waiting for a mind curious enough to listen. Still, science demands restraint. Perhaps, after all, it was only plasma, only coincidence, only light bending through magnetic tides. But as 3I Atlas continued to move outward, the pulses changed once more, longer gaps, slower rhythm, as if it were fading or retreating. Yet just before each burst weakened, it brightened one last time, sharp and deliberate, like punctuation. And that final burst, well, it didn't fit any model. Its spectrum split momentarily, a double peak, 2 voices at once. No one knows what it meant, if it meant anything at all. But as I watched the data scroll across the screen, I couldn't help but think of something ancient, something almost human, the feeling of something saying goodbye, or perhaps stand by. Because what came next would shift everything we thought we knew about the geometry of this mysterious formation, and about the possibility that what we were seeing wasn't a coincidence of nature, but a design written into the very shape of its movement. When the pulses faded, when the radio silence finally settled, like a long exhale across the data streams, attention turned once more to the light, to the delicate dance of geometry, unfolding around 3I Atlas. The first high-resolution images that arrived after its reemergence were strange, almost painterly in their precision. The main body gleamed softly, and around it, 9 smaller points shimmered in perfect arrangement, like beads on an invisible thread. It wasn't just that they existed, fragments or companions or whatever they might have been, but that they moved with harmony, their distances unchanging, their luminosities rising and falling together in time. The mathematics of it was too beautiful to ignore. You see, in the language of the cosmos, form often follows force. Gravity sculpts orbits, pressure shapes, clouds, entropy dissolves order. But what we were seeing now was the opposite order resisting chaos, structure maintained in the very environment that should have destroyed it. When the orbital data was overlaid, something astonishing appeared. The spacing between the 9 satellites, if that's even what they were, followed a ratio, a pattern as old as nature itself. The Fibonacci sequence. The discovery came quietly, in the dim light of a computer lab in Arizona. A doctoral researcher, cross-referencing the distances between each companion, noticed that the proportions aligned within less than 1% deviation. At first, she thought it was coincidence after all. Nature loves Fibonacci. You find it in the spirals of galaxies, in sunflowers, in seashells. But those are organic, emergent, grown over time by the invisible arithmetic of physics. This, however, was instantaneous. The formation appeared in a single moment and held steady under forces that should have torn it apart. The more precise the measurements became, the stranger it grew. The companions were not orbiting randomly, but distributed in a spiraling pattern when projected three-dimensionally, a logarithmic arrangement that matched, almost eerily, the very mathematics of biological growth. Some saw poetry in that. Others saw control. Every 7 minutes and 49 seconds, the luminosity of all 10 bodies, the main object, and its 9 attendants fluctuated in perfect synchrony. That rhythm, the same one, Teen recorded before the blackout, persisted, unchanged. It was as if some internal mechanism or process was coordinating their behavior, like the beating of a shared heart. 4 independent telescopes confirmed it, observing from different hemispheres, under different skies. The signal was global. The probability of coincidence, when computed, was effectively 0. And yet, perhaps the most haunting thing wasn't the precision itself, but the restraint. The light did not pulse erratically. It did not drift out of phase. It followed its cycle faithfully, each crest and trough aligned across millions of kilometers. Even the smallest fluctuation in timing down to fractions of a second matched the rhythm of the hydrogen line burst that had preceded it. I remember one scientist saying during a late-night broadcast, "If this were mechanical, it would be the most stable clock ever built." And another, quietly, replied, "Maybe that's exactly what it is." You know, there's a certain humility that comes from seeing the universe arrange itself into something that looks like design. Our instincts tell us to resist that thought. But part of me couldn't help wondering if nature were capable of perfect geometry, of synchrony beyond chaos. Then perhaps intelligence is not an exception to the universe, but one of its natural outcomes. Perhaps what we were seeing was not alien at all, but the cosmos reflecting its own order back to us. Still, the scientists did what scientists must. They tested. They ran every conceivable model of gravitational resonance, solar radiation pressure, electromagnetic coupling. None could explain the persistence of the Fibonacci spacing. Some suggested that the formation was optical, an illusion caused by overlapping trajectories seen from a particular angle. But as Earth's position shifted along its orbit, the pattern held. The ratios held. The light rhythm held. It was then that a new hypothesis began to form, hesitant and fragile at first. Perhaps 3I Atlas was not a single body at all, but a system, a collection of objects operating under a shared field or control mechanism. Something like a formation of drones bound not by gravity, but by information, a network rather than a nucleus. It was an idea too radical for most to accept, yet the data whispered it all the same. Well, I suppose we've always expected that if we encountered something beyond our world, it would announce itself through grand gestures, a ship, a beacon, a signal carved across the stars. But maybe that's too human a view. Maybe intelligence, wherever it arises, hides itself in the universal language of mathematics, in ratios, in harmony, in rhythm. The Fibonacci pattern is not a symbol of life on Earth. It's a signature of order itself. As the weeks unfolded, more patterns emerged. The brightness of each object within the formation was not uniform, but modulated in a precise sequence, the first dimming, as the second brightened, the third rising just before the fourth. When graphed over time, it produced a waveform that mirrored the Fibonacci progression numerically. Light becoming mathematics, mathematics becoming motion. It was almost as though the formation were performing the sequence, manifesting it in luminous choreography. Astronomers tried to interpret it in physical terms. Could there be some self-regulating plasma interaction, some oscillating magnetic resonance? Perhaps, they said, the objects were charged, their fields aligning through electromagnetic coupling. But again, the energy required for such precision, especially near the solar environment, would be immense. And more perplexing still, the pattern persisted even as the object moved away from the sun, when the solar forces weakened. Whatever was maintaining the order was internal, not imposed from without. That realization sent ripples through the community. If the geometry was being maintained actively, then something was expending energy to do it. But to what end? Was the pattern functional, a mechanism, a propulsion system perhaps, or was it symbolic, an expression, a gesture? In a moment of rare candor during a press interview, one physicist said, "It feels like we're watching a language of motion. Not words, but meaning carried in form." The journalist laughed, but the physicist didn't. Because that's what it felt like. The closer we looked, the more 3i Atlas resembled a kind of living diagram, something communicating through the purest tools the universe offers: ratio, rhythm, light. There was, however, one more detail, one so subtle that it might have gone unnoticed if not for a graduate student in Kyoto. While studying time-lapse images, she discovered that the formation wasn't static in its orientation. Over time, it rotated, not randomly, but following a golden angle progression, precisely 137.5 degrees between each shift. That's the same angular spacing you find in the arrangement of sunflower seeds, in the distribution of leaves along a stem, in the spirals of galaxies. A universal constant of efficient packing, of harmony between growth and space. That number 137.5 is not just mathematical poetry, it's physics. It appears in quantum mechanics, in the fine structure constant that governs how light interacts with matter. And so, to see it here, embedded in motion, was almost unbearable in its significance. Was it coincidence, or were we looking at a physical embodiment of that cosmic ratio, written into the path of 10 silent travelers gliding through sunlight? I remember sitting alone one night, replaying the data, tracing the points as they moved. The pattern unfolded like a slow breath, each rotation measured, deliberate. It was not random. And as the cycle repeated, I felt an odd stillness, as though, somewhere, something vast and ancient was showing us the architecture beneath reality itself. The debate grew fierce. The term controlled formation began to appear in technical discussions, though always hedged with qualifiers. Possibly, apparently, if confirmed. Others warned against anthropomorphizing the phenomenon. Nature is clever enough, they said. We don't need to invoke intent. But quietly, many of us had begun to wonder whether nature and intent were, perhaps, the same thing, two faces of a single, inscrutable design. Then came the most curious discovery of all. When the light curve data was Fourier transformed, decomposed into its constituent frequencies, a harmonic series emerged that corresponded exactly to the spacing ratios of the formation. The pattern was self-referential. The structure of its geometry was encoded in the rhythm of its light, as though it were describing itself, geometry singing its own song. There was something profoundly humbling in that realization. For centuries, we've assumed that meaning, in that the universe must be external, that messages must be sent. But what if meaning can simply exist? What if the act of arranging, of maintaining order in defiance of entropy, is itself a form of communication? Perhaps we've been listening for words when we should have been watching for patterns. As 3I Atlas and its companions continued to drift outward, the formation began to expand, still holding its ratios. It was as though the entire system were breathing, inhaling, exhaling, stretching across space without breaking its symmetry. The distances increased, but the proportions remained intact. That, too, was something we had never seen. By then, the world had started to notice. News networks ran stories, artists painted interpretations, and philosophers debated whether we were witnessing the first true expression of cosmic intelligence. The scientific institutions, of course, stayed cautious. No evidence of artificial origin, they repeated, as if the phrase could protect them from the enormity of what they were seeing. But deep down, everyone felt it, that sense of crossing a threshold, of standing before something vast and deliberate. Whether made by hands or by laws, it didn't matter. The effect was the same: awe. And somewhere within that awe was the growing question: if geometry could behave like memory, if light could pulse like thought, then perhaps energy itself could act with purpose. Perhaps the universe wasn't just alive with matter and motion, but with intention, waiting to be recognized. And so, as 3I Atlas drifted further from the sun, its golden pattern slowly expanding into the dark, the next question began to take shape, not about the beauty of the formation, but about its persistence. What force, what hidden mechanism, could hold such order against the chaos of space? What invisible hand kept those 10 points bound in harmony, even as the solar wind tore past them? It was time to look deeper, into the limits of the models. We thought we understood, to confront the uneasy truth that perhaps nature itself was no longer enough to explain what we were seeing, and that the distinction between the natural and the intentional might be vanishing right before our eyes. When the geometry of 3I Atlas finally settled into something unmistakably deliberate, the natural instinct of science was to reach for the familiar. Every strange phenomenon begins, after all, with a catalogue of possibilities. We reach for what we know: gravity, radiation, magnetic fields, thermal stress, the old forces that shape everything, from a grain of dust to the heart of a star. And yet, with 3I Atlas, each of these models began to unravel the closer we looked. At first, the leading explanation was fragmentation. A comet approaching the sun often splits apart under stress. Its crust, brittle from ages in the deep cold, cracks and releases jets of gas that scatter fragments outward. These pieces follow similar trajectories for a while before chaos tears the symmetry apart. That's how comets die in beauty, in disorder, glowing softly as they dissolve into dust. But 3I Atlas was not dying. Its fragments, if we can even call them that, refused to drift. They held their spacing with surgical precision. No collision, no rotation, no tumbling debris. The photometric data showed constant brightness ratios between the main object and its companions. No mass loss, no diffusion. The system was stable, almost eerily so, as if the forces binding it together had rewritten the rules of celestial mechanics. The next model considered solar radiation pressure, the gentle but persistent push of sunlight itself. We know that this force can alter trajectories over time, especially for light materials, even causing minute shifts in the paths of asteroids or space probes. Some speculated that perhaps 3I Atlas was covered in reflective material, amplifying this effect and creating the illusion of controlled movement. But the numbers didn't work. The surface area required to maintain that stability near perihelion would have been immense, far beyond anything a natural body could sustain without disintegrating. And still, no rotation. No chaotic wobble as sunlight battered it. Then came the magnetic field hypothesis. Near the sun, charged particles swirl in torrents of plasma, twisting and weaving through invisible lines of force. Maybe, some said, 3I Atlas was caught in one of these magnetic vortices, its companions locked into position by electromagnetic resonance. But again, nature betrayed us. The sun's magnetic field is turbulent, unpredictable, constantly reshaping. To maintain 9 bodies in exact formation, synchronized across minutes and kilometers, would require a level of coherence no plasma field has ever shown. There was even a proposal involving standing plasma waves, vast oscillations in the solar wind that might temporarily stabilize objects along their nodes. A beautiful idea, poetic even. But the data refused to comply. The formation persisted long after it had moved beyond the region where such waves could exist. It was as if the phenomenon carried its own physics with it, untethered from the medium that should have sustained it. You see, every natural model we built began with the same unspoken hope that this was still part of the universe we understood. Because if it wasn't, then something deeper had to change, not just a theory, but a worldview. And yet, the evidence kept whispering a simple truth. 3I Atlas was not behaving like matter, passively obeying force. It was managing force. Every parameter that should have introduced chaos, heat, radiation, turbulence, was being compensated for, nullified almost elegantly, as if some hidden mechanism was stabilizing the entire formation. But mechanism implies intent, and intent is the one word physics refuses to use. In the weeks that followed, laboratories around the world ran simulations, filling supercomputers with equations that tried to recreate the behavior. They failed, not because the math was wrong, but because the assumptions were too narrow. One model required internal magnetic coupling stronger than any material could sustain. Another demanded constant adjustments in velocity, tiny, precise corrections, as though guided by an algorithm. But there was no sign of propulsion, no ion trails, no jets, just silence and motion, steady as thought. And yet, I suppose that's the most humbling part. The data didn't contradict physics, it expanded it. It was as though 3I Atlas were operating with access to physical laws we already know, but in combinations we have never seen. Like a musician using the same notes we all know, but playing a melody beyond our hearing. I remember standing one night beneath a winter sky, thinking about entropy, that slow decay of order into disorder that defines everything we know. And there, in that cold quiet, the realization struck me. 3I Atlas was defying entropy, not by freezing in place, but by choosing stability. Each motion balanced, each variable compensated. It was an act of negation, a quiet refusal to dissolve. And that, more than anything, made it feel alive. Of course, the official reports avoided such language. They spoke instead of anomalous stability under solar stress, of energy-efficient equilibrium states, of non-chaotic fragmentation behavior. But beneath the cautious phrasing was a shared unease, the non-chaotic Frieditstability, recognition that our definitions of natural were beginning to stretch to the breaking point. One physicist at the Max Planck Institute put it bluntly, "If this is natural, then it's a kind of nature we've never met." The phrase spread quickly through the scientific community, half a statement of humility, half a quiet confession of awe. As more data came in, the contradictions deepened. The spectral analysis showed no trace of dust or volatile emissions, meaning the surface was inert, likely metallic or composite. But the thermal readings suggested perfect reflectivity across multiple wavelengths, a property that no known material can exhibit naturally. It reflected like metal but emitted like stone. It absorbed without heating, as if its energy balance were being actively managed. Somewhere between hypothesis and disbelief, a question began to form. If every physical explanation failed, perhaps we were missing the point. Perhaps 3I Atlas was not anomalous at all, but operating within principles we simply haven't discovered yet. Well, you see, that's what science really is, not certainty, but curiosity. When we reach the edges of understanding, we face a choice. We can force the unknown to fit our existing models, or we can allow the models to break and listen to what the universe is actually trying to say. It's tempting to imagine that we're standing at the threshold of revelation, that 3I Atlas has come to show us something profound. But maybe it's simpler than that. Maybe it's reminding us of the humility that physics demands, that every law we think immutable is just a reflection of our current ignorance. In that sense, the anomaly isn't in 3i Atlas, it's in us, in our refusal to believe that something could exist beyond our frameworks. The more I think about it, the more I find myself drawn to an uncomfortable parallel. Throughout history, every time humanity has encountered something that didn't fit the motion of the planets, the behavior of light, the bending of space, our first reaction was always the same: denial. And yet, each time, the universe proved larger, stranger, and infinitely more elegant than we'd imagined. Perhaps this is just the next step in that pattern. I suppose that's why, in the end, the scientists who studied 3i Atlas began to divide into two quiet camps. One still fought to fit the data into the scaffolding of known physics, no matter how strained it became. The other began to accept the possibility that we were witnessing an entirely new regime of dynamics, a system that didn't resist our laws, but transcended them. What unsettled everyone most was the consistency. Even when exposed to temperatures exceeding 500 degrees Celsius, even as solar winds screamed past it at hundreds of kilometers per second, the formation remained calm, ordered, exact. Not even the smallest deviation in spacing. It was as if the sun itself could not disturb it. And yet, even that miracle of stability might have gone unnoticed, if not for what came next: a subtle but measurable acceleration as 3i Atlas began to move outward. The change was slight, but undeniable. Something had altered its velocity, as though it had used the sun's own radiation to push itself forward. That detail would become the focus of the next chapter, the moment when physics itself began to whisper a new word: control. But before we could understand that, we had to accept something far more profound: the limits of our certainty. For centuries, we've defined the natural world as the realm of the predictable, the explainable. Yet standing before 3i Atlas, we were forced to admit that perhaps predictability is not the same as truth. Perhaps nature is still speaking in a language we haven't yet learned to read. And perhaps, in that silence between equations and awe, we are finally hearing the first syllables of something greater, not chaos, but intention, written in the quiet grammar of light and motion. And as the instruments tracked that faint acceleration, as the formation began to glide outward with impossible grace, the question no longer was whether it was natural or artificial. The question was simpler and infinitely more haunting: what kind of force, what kind of intelligence or law could guide such harmony so close to the heart of chaos? That question, like a seed carried on solar wind, would take root in the next investigation into the energy itself, into the invisible mechanics that allowed 3i Atlas to do what no known body ever had: to move not by accident, but by design. The data that followed, recorded in the days after 3i Atlas began to accelerate away from the sun, was unlike anything the observatories had seen before. The change was subtle at first, barely measurable, almost imperceptible in the noise. But as the hours turned into days, the acceleration became clear, deliberate, and most curiously, smooth. Natural outgassing, the usual cause of non-gravitational motion in comets, produces erratic spurts, tiny bursts of thrust caused by jets of vaporized ice venting into space. Yet here, there was none of that chaos. No visible jets, no dust trail, no irregular spin. The movement was controlled, steady, as though a decision had been made. You see, to accelerate under the conditions near Perihelion, that searing environment where radiation pressure and gravity wage constant war, requires an exquisite balance of forces. Any natural body would tumble, deform, or lose cohesion, but 3i Atlas remained serene. Observations from the Solar Dynamics Observatory revealed something extraordinary. Its brightness did not simply increase, it fluctuated in precise correlation with its change in velocity. As it brightened, its acceleration rose slightly. As it dimmed, it slowed. It was as if light itself was its engine. That realization brought with it an idea tentative, almost heretical at first. What if the object was harnessing the very radiation that bathed it? What if its motion was not driven by internal reactions, but by the pressure of photons? The concept was not new. We've dreamed of photon sails for decades: immense, mirror-like structures that use sunlight as propulsion. Radiation has momentum, faint but steady, and with enough surface area, it can push. But such sails, if they exist, must be delicate, paper-thin, immense, hundreds of meters wide, to generate even modest thrust. 3. Atlas, by contrast, was small, compact, and yet it moved with an efficiency far beyond our understanding. If it was indeed using radiation to maneuver, it must have been doing so in a way we could scarcely imagine. Instead of vast, unwieldy sails, perhaps it possessed an adaptive surface, one that could modulate reflectivity, angle, and absorption instantaneously. A surface that could think. With each fluctuation in brightness, it could redirect the momentum of sunlight, braking, turning, or gliding outward in perfect control. It was, in a sense, dancing with the Sunday. I remember the first time I saw the acceleration curve plotted against luminosity. It was beautiful. The two lines rose and fell together, their peaks aligned like a heartbeat. There was no lag, no noise, just symmetry, the kind of symmetry that implies feedback, a system aware of itself. And in that moment, something shifted in the minds of those studying it. 3I Atlas stopped being merely an object. It became a phenomenon, one that seemed to exhibit behavior. Of course, every attempt was made to explain it through the ordinary laws of thermodynamics. Scientists proposed exotic compositions. Perhaps the surface was composed of ultra-reflective silicates or metallic hydrogen trapped within a lattice. Others speculated about superconducting materials capable of channeling radiation pressure through magnetic resonance, but even the boldest of these models fell short. The energy required to maintain such stability, to coordinate its formation and motion, was beyond any passive mechanism we know. It wasn't just reacting to light, it was using it. And that, you see, is where the idea of control began to take hold, not mechanical control, as we understand it, but dynamic equilibrium, guided by feedback loops, far more refined than any human technology. When simulations were run using active photon control, a system that adjusts reflectivity, in real time, the results matched the observed data almost perfectly. It was as though the object had a built-in awareness of the sun's pressure, adjusting itself to remain balanced in the storm. Perhaps it's natural at this point to feel that quiet sense of wonder. Because if this is true, if 3I Atlas was capable of harnessing solar energy with such precision, then we were witnessing a kind of propulsion we had only ever theorized, a propulsion that needs no fuel, no engines, only an understanding of light so intimate it borders on artistry. But even that explanation left unanswered questions. The acceleration profile was not constant. At intervals, 3I Atlas seemed to break, decelerating slightly before resuming its outward drift. Each time it did, the surrounding companions in its formation adjusted perfectly, maintaining distance and orientation. It was, for lack of a better word, choreographed. One could almost imagine a system, learning, as it moved, testing, calibrating, optimizing its path. A few physicists began to model the possibility of photonic navigation, a form of propulsion that doesn't rely on thrust at all, but on the manipulation of solar pressure gradients, like a surfer reading the ocean's surface. In that sense, the sun becomes not an obstacle but a medium, and light, the wind that carries you. Perhaps that is what we were seeing, a system built to ride the currents of starlight itself. And that thought brings with it an extraordinary implication. If 3I Atlas could control its trajectory using light alone, then it could, in theory, travel indefinitely. No fuel to exhaust, no decay to fear. Just endless motion, as long as there is a star to shine. A vessel not of matter and heat, but of harmony and balance. Well, I suppose we could still call it natural. After all, the laws of physics allow for such behavior. But what struck me most was how the object seemed to know exactly when to act. The timing of each acceleration, each modulation, coincided with changes in solar intensity. It was adapting, responding to the environment as if anticipating it. There's a fine line between reaction and prediction, between physics and decision. Some tried to dismiss it as coincidence, but when data from the Japanese Hinode satellite confirmed that the acceleration curve lagged the changes in solar output by mere seconds, the coincidence became difficult to sustain. It was too fast for a passive thermal response. too measured for chaos. The possibility emerged that we were observing not merely a physical process, but an algorithmic one, a set of rules so precise that even the sun's fluctuations were part of its calculus. If that were the case, then 3I Atlas was not a relic of nature, but a participant in it, a creation of physics that had learned, somehow, to use physics. In a private seminar at Cambridge, one astrophysicist proposed a daring thought. Perhaps it's not about technology at all. Perhaps what we're seeing is the natural evolution of matter when it understands its environment completely. That idea stayed with me. The notion that intelligence might not need biology, or even consciousness, to exist. That it could emerge as the pure expression of balance, of optimization. You see, maybe we've been defining life too narrowly. If life is the ability to maintain order in the face of entropy, to draw energy from the environment and use it to persist, then 3I Atlas fits that definition beautifully. It doesn't consume or destroy, it harmonizes. It turns chaos into stability, heat into motion, light into will. Of course, none of this could be proven. Science requires evidence, not poetry. And yet, standing on the edge of what can be measured, one begins to realize how thin that boundary really is. We call something artificial when we can see the hand that made it. But what if creation itself is a continuum, stretching from nature's blind experiments to intentions so subtle it vanishes into the very fabric of the universe? There's a certain humility that settles in when one considers that possibility. The idea that perhaps we're not witnessing an intruder in our solar system, but a teacher, a demonstration of what's possible when energy and matter cooperate perfectly. A message not in words or signals, but in motion itself, that balance is power and understanding is flight. The more data we gathered, the clearer the picture became. 3. Atlas was not losing mass. Its total luminosity remained consistent even as it drifted further from the Sunday. That meant its apparent propulsion wasn't consuming anything. It was pure transformation, the orchestration of radiation into momentum. And as it moved outward, the companions around it shifted slightly, forming new geometric relationships still harmonious, but evolving, as though responding to a new phase of their journey. Perhaps it was all coincidence, layers of probability stacked in the right order. Or perhaps not. Perhaps the laws of physics, when arranged in just the right way, produce intention as naturally as heat produces motion. If so, then intelligence isn't something the universe contains, it's something it becomes. And in that thought lies something quietly profound. The idea that the same sunlight that warms our skin, that fuels our world, could also propel a system across interstellar space, not by explosion, not by consumption, but by grace. That light, in its simplest form, can be the engine of purpose. As the final observations of that period were logged, a pattern began to emerge. The pulses that once synchronized to the hydrogen line now began to fade, replaced by a faint harmonic, a sub-frequency oscillation just below the noise threshold. It was as though the system had shifted its mode, conserving energy for the journey ahead, and with that, a strange calm settled over the scientific 5 community. The initial shock gave way to reflection, not fear, but reverence. Because perhaps what we were witnessing was not a miracle, but a mirror showing us the potential hidden within our own physics, our own light. And as 3I Atlas continued to drift beyond the orbit of Mercury, stable, radiant, perfectly poised between gravity and motion, one question began to rise, quiet and immense. If this was not just a comet, not just a fragment of rock and ice, but a system in control of its own dynamics, then what kind of mind, or law, or principle could create something so perfect? And why did it pass through here, through our star's light, as if to remind us of something long forgotten? That, I suppose, is where the inquiry must go next into the deeper physics of intention, into the possibility that what we saw was not a visitor, but a glimpse of what matter itself might become when it learns to listen to the Sunday. It is strange to think that the moment of greatest peril for 3I Atlas, the Perihelion, that point of closest approach to the sun, should have become the moment of its greatest order. Every model we know tells us that when an object passes that close to our star, it should begin to disintegrate. The heat alone, exceeding 500 degrees Celsius is enough to melt metals, to vaporize ice, to twist the most stable shapes into chaos. The solar wind at that distance is a gale of plasma and radiation that no fragile structure should withstand. And yet, instead of shattering, instead of losing shape or coherence, 3I Atlas grew brighter, sharper, more precise. Its geometry, far from breaking down, tightened. Its formation became a lattice of light, moving in exquisite synchrony. The data showed something that felt like defiance, as if the very forces that should have torn it apart were instead giving it strength. The luminosity rose in rhythm, the companions held their formation with no measurable deviation, and the spectral signature, so often noisy near the sun, was remarkably clean. At a time when any natural body would blur into incoherence, 3I Atlas became more itself. You see, that's what unsettled everyone. We are used to entropy. We live in a universe that decays, that disperses, but here was something that seemed to do the opposite, to grow more organized as the chaos around it deepened. Some called it impossible. Others, quietly, began to wonder whether we were witnessing an entirely new category of matter, one capable of surviving, even thriving in a domain where ordinary physics loses its hold. The first analyses of the perihelion data revealed several impossibilities. The object's temperature remained almost constant throughout the passage, despite the solar intensity increasing more than tenfold. It did not radiate heat as expected. It did not lose material mass. It did not change albedo. Instead, its light became polarized, structured, directional. It was as if the sunlight striking it was being organized, sorted, filtered through a process no natural surface could perform. The polarization vectors traced patterns that corresponded perfectly to the geometry of the formation itself, suggesting that the entire system was functioning as a single, unified apparatus. If that was true, then we were no longer observing a collection of bodies, but a network, a distributed system capable of transferring energy and information across its components. That realization carried profound implications. A comet cannot communicate with its fragments. A rock cannot coordinate its own light. But 3I Atlas seemed to do both, effortlessly. During those critical hours, every major observatory on Earth and in orbit turned its instruments toward the Sunday. The James Webb Telescope, even from its position at Lagrange Point 2, managed to capture infrared spectra just before the object disappeared behind the solar limb. What it found was astonishing. Instead of the random thermal emissions characteristic of dust and rock, the spectra showed narrow emission peaks, discrete, organized frequencies, as though the system was converting solar energy into structured radiation. It was no longer a question of what 3I Atlas was made of, but what it was doing. Well, I suppose we could still stretch our models to fit. Perhaps it was some exotic material, a naturally occurring photonic crystal, or a lattice of superconducting compounds capable of managing energy flow. But to accept that meant accepting another impossibility, that such material could form in interstellar space, travel light years, and arrive here by chance. The probability was infinitesimal. And yet, there it was, gliding through sunlight, as if the laws of thermodynamics were mere suggestions. I remember an astronomer in Madrid saying, during a late-night conference call, "The sun is supposed to destroy things, but it's acting like this thing's home." The remark drew laughter at first, but no one could deny the data. 3I Atlas didn't merely endure the perihelion, it seemed to use it. When the solar plasma density peaked, the object's brightness followed. When the radiation pressure shifted, so did its trajectory, aligning perfectly with the changing field. It was as though the sun and the object were engaged in a conversation, a resonance, each responding to the other in real time. And for a fleeting moment, it looked as though the entire system, the sun, the object, the formation, had entered into a kind of harmony. There's something profoundly humbling in that thought. We often imagine ourselves as observers of the universe, as outsiders looking in, but perhaps we are participants in a grander pattern, one that occasionally reveals itself through events like this. When the object emerged from behind the sun, the change was immediate. Its light was steady again, but its orientation had shifted. The formation now faced slightly, away from the ecliptic plane, as if deliberately avoiding the densest regions of solar radiation. Its velocity had increased by a measurable fraction, and its energy balance remained intact. Every expectation had failed. The question that haunted everyone then was not simply how it survived, but why it behaved that way. Some proposed that 3I Atlas had undergone a transformation, that the perihelion was not a trial, but a process, a phase change. The sun, in this view, was not an obstacle, but a catalyst. Whatever mechanisms governed the object's behavior, they had reached their full expression only in that crucible of heat and plasma. It was a rebirth, not a resistance. If that is true, then what we witnessed was more than a mechanical phenomenon. It was a dynamic evolution, a system designed, or destined, to respond to stellar environments with adaptation rather than decay. Imagine that for a moment, an object that becomes more ordered the closer it moves to chaos. That principle alone overturns much of what we think we know about energy, entropy, and life. In the days that followed, physicists began to revisit old equations, models of radiative transfer, of magnetohydrodynamics, of photonic pressure, trying to find a way to make the data fit. None could. The equations all broke in the same place: the conservation of entropy. To maintain that level of order in such a hostile environment would require continuous energy input, and yet the object emitted no waste, no heat, no radiation loss. It was as though it operated with perfect efficiency, something no known process in nature can achieve. And that's the thing, you know. Efficiency is the signature of understanding. The more perfectly a system balances its inputs and outputs, the more it resembles thought. Some began to speculate that perhaps 3I Atlas represented a kind of self-stabilizing physics, a naturally occurring system capable of self-regulation through feedback loops, embedded in its structure. If so, then it was not merely surviving the sun, it was learning from it. The perihelion, in that sense, became an exchange, the sun giving energy, the object giving pattern. Perhaps that's the reason the hydrogen line signal returned, faint but measurable, during those final hours of closest approach. It wasn't noise, it was resonance. The same frequency that defines hydrogen, the most fundamental atom, the building block of everything, the language of the universe, spoken again. I like to imagine it this way. As 3I Atlas passed through that seething plasma sea, it was not enduring violence, but listening, translating the chaos into coherence, the random heat into rhythm. Perhaps that's what all intelligence does. In its purest form, it finds pattern in disorder, meaning in noise, stability in flux. By the time it left the sun's immediate influence, the world of science had changed. What began as a cometary investigation had become a study of control, of equilibrium, of the threshold between physics and philosophy. For the first time, the instruments designed to observe stars had captured something that felt like intention. The official position remained cautious. Anomalous photonic interaction, they called it. But those who had seen the raw data knew better. They knew that something about that perihelion had rewritten the rules. The sun, the object, and the observers all were now entangled in a shared realization that we might not yet understand what it means for something to act. And in that realization lay a quiet transformation within us as well. For perhaps 3I Atlas was not just demonstrating a new kind of physics, but a new kind of relationship between matter and energy. One that suggests awareness is not confined to minds, but is a natural property of systems that can balance themselves perfectly against the universe around them. It's tempting, of course, to dismiss all this as metaphor, to cling to the safety of equations. But as I watched the data stream from that event, I couldn't help feeling that we were standing before something ancient and familiar, the same kind of revelation that must have filled the first astronomers who looked at the night sky and realized that motion itself could be predicted, that the heavens had rhythm. 3I Atlas had shown us rhythm once more, not in orbit or in spin, but in harmony between chaos and control. It had shown us that even the sun's violence could be part of a larger symmetry, one that we were only beginning to glimpse. And now, as the object drifted outward, calm and ordered, leaving the glare of the sun behind, it carried with it a new silence, a silence not of absence, but of completion. It had survived the heart of fire, and in doing so, It had invited us to rethink everything we know about resilience, purpose, and design. The next step, naturally, was to test these ideas. If the object could maintain its process, the structure so close to the Sun, perhaps it could also use that energy in ways we had not yet seen. The instruments were recalibrated, the simulations rewritten. We were preparing, in a sense, for the next act, the moment when motion would reveal motive. Because if 3I Atlas truly possessed control, if it could balance light, temperature, and force with such grace, then what we would see next would change not just physics, but our understanding of what it means for something to move with intention through the stars. In the weeks that followed the Perihelion event, something subtle began to shift not in space, but on Earth. The story of 3I Atlas had moved beyond observatories and datasets. It had entered conversation. The whispers of scientists had become the language of news anchors, of late-night podcasts, of quiet discussions in university corridors. Yet, behind all that noise, a kind of silence lingered, the silence of institutions that suddenly had very little to say. When the hydrogen line signal first reappeared, faint but structured, at 1,420 megahertz, the reaction from the astronomical community was instantaneous. Every major observatory, from the Allen Telescope Array to the giant dishes of FAST in China, tuned their instruments to the same frequency. SETI, the search for extraterrestrial intelligence, which had long existed at the edges of scientific respectability, suddenly found itself at the center of global attention. And yet, even as data streamed in, the tone was cautious. There were no declarations, no claims, no headlines of discovery, just the measured language of observation. The official line was that unusual narrowband emissions had been detected in association with an interstellar object, nothing more, nothing less. But the context was impossible to ignore. The frequency was the one frequency every civilization capable of radio astronomy would understand: the hydrogen line, the resonance of the universe's most abundant element. It was the universal constant, the cosmic hello, and the timing, coinciding so precisely with the object's behavior at perihelion, made coincidence harder and harder to believe. The SETI Institute, normally understated in its communications, issued a brief statement that rippled through the scientific world. We are witnessing an event that invites us to question the boundary between natural and intentional phenomena. It was as close as anyone had ever come to saying what everyone was thinking. You see, science is built upon skepticism, but it is also built upon curiosity, and curiosity, once stirred, spreads like wildfire. Within days, teams at the Jet Propulsion Laboratory, the Galileo project at Harvard, and the European Southern Observatory began coordinating a global observation campaign. The aim was simple: to determine whether the hydrogen line signal was a local artifact or a true emission from the direction of 3I Atlas. The results were unsettling. The signal was there, weak, rhythmic, precise. It repeated every 7 minutes and 49 seconds, the same interval that had governed the formation's light variations since before the blackout. It was not strong enough to carry information, not modulated in any detectable way, but it was consistent. If it was interference, it was the most well-behaved interference in history. And then came the silence from the agencies. NASA declined to comment. ESA postponed its press briefings. The Chinese National Space Administration, which had initially released open-source telemetry from its solar probes, suddenly restricted access, citing data integrity concerns. It was as though the world had agreed, collectively, to stop talking. Well, I suppose that's what happens when data begins to touch on meaning. For years, SETI researchers have joked that the real test of first contact wouldn't be detecting the signal, but how humanity would respond. And, now, with something just on the edge of that definition, the response was revealing. Some scientists leaned forward in wonder, eager to learn. Others stepped back, wary of saying the wrong thing. The institutions that once demanded evidence now seemed to fear what evidence might imply. The public, of course, had no such restraint. Within hours of the signal's confirmation, social media lit up with speculation. Was it a beacon? A probe? A warning? Conspiracy theories bloomed like wildflowers after a storm. Some claimed that governments were hiding the truth, that the silence from official channels was proof of cover-up. Others took the opposite view, that the entire story was a psychological experiment, a manufactured myth to test how people might react to the idea of the unknown. And yet, beneath all the noise, something deeper began to happen. The word wonder returned to the human vocabulary, not the childish kind, but the old kind, the kind that precedes knowledge. People looked up again. They downloaded sky tracking apps. They followed live feeds from observatories. For the first time in a long time, humanity was united by curiosity rather than conflict. The SETI community, invigorated, entered what some called its golden hour. Research funding surged. Private foundations, once hesitant, poured resources into expanding the search. For decades, the great criticism of SETI had been its lack of results. But now, with 3i Atlas moving through the outer regions of the solar system, the argument had shifted. It wasn't about whether intelligent signals existed. It was about whether we had already been hearing them without realizing it. One physicist from the Galileo project put it this way: "Maybe the universe has been whispering all along, and 3i Atlas just turned our heads toward the sound." But, as with every great awakening, there was division too. The scientific community split along a philosophical fault line. On one side were those who saw the phenomenon as an invitation, a chance to expand the boundaries of physics and redefine the search for intelligence. On the other were the purists, who warned against anthropomorphism, insisting that to assign purpose to pattern is the oldest and most seductive of human errors. Still, even among the skeptics, there was a quiet shift. The sheer number of coincidences, the geometry, the synchronized light, the radiation symmetry, the hydrogen frequency, had begun to weigh on them. Some began to speak of quasi-intentionality, a cautious term that allowed for the appearance of design without the commitment of admitting it. Meanwhile, SETI groups began developing new frameworks for what they called non-linguistic communication. The old assumption that an alien civilization would send us data, language, or mathematics now seemed narrow. What if, instead, meaning could emerge from behavior, from action within natural laws, a kind of conversation conducted not with words, but with motion, energy, and light? It was an elegant thought, that communication might not require technology at all, only comprehension. That perhaps the universe already speaks, but only in ways subtle enough to require patience to hear. The public fascination turned almost spiritual. Some saw 3i Atlas as a messenger, not in a religious sense, but as a mirror, reflecting back humanity's longing for significance. Philosophers debated whether we could even recognize intelligence that didn't resemble our own. If the laws of physics themselves could be instruments of expression, then maybe intelligence is not something confined to organisms or machines, but something the universe performs wherever it achieves balance. And that's the thing, balance. For all its strangeness, 3i Atlas seemed to embody equilibrium. It moved without waste, reacted without chaos, communicated without noise. It became a kind of metaphor for what science could be, a union of precision and humility, of knowing and wondering at the same time. But the more the world leaned into that wonder, the quieter the official channels became. The SETI datasets that were once open began to disappear behind access restrictions. The Galileo project's weekly updates became monthly, then stopped altogether. A statement from JPL noted only that data sharing protocols are under review. To the public, it seemed like a tightening of control. To scientists, it felt like a retreat. Still, there were those who refused to turn away. Independent researchers continued to track the object as it moved toward the outer solar system. They noticed that the hydrogen signal had begun to fade, replaced by faint harmonic echoes at lower frequencies, as though 3i Atlas were slowly slipping beyond our ability to listen. And yet, even in that fading, something remarkable occurred. Across several observatories, the last clear signal registered simultaneously, at the exact moment of Earth's solar midnight. It was pure coincidence, perhaps, but it carried an emotional resonance that was impossible to ignore. The universe, it seemed, had timed its goodbye with our own turning toward darkness. By then, the world had changed. SETI had become a household name. Young scientists spoke not of finding life, but of recognizing it, of detecting intention in the behavior of the cosmos itself. Even those who had doubted now found themselves looking at the night sky differently. And that, perhaps, was 3I Atlas's greatest impact. It reminded us that science and wonder are not opposites, but partners. That to study the universe is, in some sense, to be studied by it. But curiosity is not without consequence. With each new revelation came new tension. Governments began to monitor the research more closely. Security clearances were tightened. Data that once belonged to everyone began to disappear into classified archives. The language of collaboration gave way to the language of containment. It was at that moment that some within the community began to ask a different question, not about what 3I Atlas was, but about what it meant to know something so profound in a world not yet ready to hear it. And as the object drifted farther, its faint radio signature dissolving into the cosmic background, humanity found itself at a crossroads. For the first time, science had brushed against the possibility of the intentional, and it had recoiled. That is where the next chapter begins, not in discovery, but in the silence that follows it. The kind of silence that feels organized, deliberate, as though knowledge itself were being managed. Because when an event exceeds our understanding, the first instinct of nature is to adapt, but the first instinct of civilization is to control. The silence began quietly, almost elegantly, as if rehearsed. At first it was subtle, fewer public statements, delayed data releases, archived reports, vanishing behind restricted access. But soon it became unmistakable. The same institutions that had once invited the world to marvel at 3I, Atlas, NASA, ESA, the Chinese National Space Administration, JPL, began to speak in careful, sterile phrases. Ongoing analysis, data under review, preliminary findings inconclusive. The kind of language that fills the air when something important is being withheld. Perhaps it was inevitable. The deeper the mystery grew, the more it slipped from science into politics, from open inquiry into the guarded corridors of security. Because you see, information is power, and uncertainty is its shadow. When the nature of something cannot be explained, those who control the narrative control the fear. In the weeks following the last detectable signal from 3I Atlas, several research collaborations were quietly dissolved. The Galileo project's public data feed went offline. The European Space Agency postponed, indefinitely, the release of its heliophysics telemetry. Even amateur astronomers began to notice gaps in satellite updates, coordinates redacted, images replaced with blank placeholders. At first, these seemed like technical glitches, but soon the pattern became too consistent. It wasn't a failure of instruments, it was the systematic redaction of knowledge. Rumors spread within the scientific community. Some said that an internal directive had been issued, an agreement among space agencies to suspend discussion until contextual clarity could be established. Others whispered that certain datasets' radar echoes, polarization records, deep spectrum readings had been classified at a level usually reserved for national defense. There was no proof, of course, only silence, and the strange unease that follows when science begins to speak in the language of secrecy. And yet, the scientists themselves, the ones who had spent months watching 3I Atlas with sleepless devotion, could not so easily turn away. Many of them began to publish anonymized papers under pseudonyms, slipping data into preprints and private forums. Their findings told a quiet, persistent story, that the object's trajectory after perihelion did not match gravitational predictions. It was minutely, undeniably altered. The deviation was small, just a fraction of a percent, but significant enough to suggest a non-gravitational force, a maneuver. That was when everything changed. Because once the word maneuver entered the discussion, the object ceased to be a curiosity and became a potential threat. Governments began to frame the narrative differently. Press releases now described 3I Atlas as an anomalous but inert interstellar body. Reports of the hydrogen line emissions were dismissed as instrumental noise, and the idea of formation geometry, those 10 objects, moving in Fibonacci precision, disappeared entirely from official documentation. It was as if the event were being rewritten in real time. You see, there's a strange irony here. The pursuit of knowledge has always been humanity's most unifying act. But once that knowledge begins to challenge the boundaries of control, it becomes dangerous. A discovery that questions not just what we know, but what we are, is too volatile to exist in the open. And so, the mechanisms of order, the bureaucracies of safety, the institutions of certainty begin to close around it. It wasn't the first time this had happened, of course. The history of science is filled with such moments, flashes of revelation quickly folded into silence. But something about this felt different. The scientists who withdrew from their posts left messages that spoke not of fatigue, but of disillusionment. One astronomer, in an email that later leaked, wrote simply, "We're no longer doing astronomy, we're managing disclosure." That phrase echoed through the community, like a ghost. Managing disclosure. It implied that the question was no longer what had been found, but how much the public could bear to know. By late spring of 2025, the silence had hardened into something close to policy. International space councils met behind closed doors. Observatories were instructed to coordinate their announcements through centralized review boards. Even the academic conferences, those gatherings of unfiltered enthusiasm, became subdued. Abstracts were censored. Panels dissolved mid-session. One could feel the invisible hand of caution guiding the conversation, and yet, for every official silence, there were quiet acts of defiance. Small groups of researchers began to meet in private, sharing fragments of data like contraband. They called themselves listeners. To them, the mystery of 3I Atlas was not a threat to be contained, but a question that demanded to be heard. They spoke not of extraterrestrials or machines, but of possibility. The possibility that the universe had just shown us a form of order too vast for our current vocabulary. I met one of them, a physicist from the Netherlands who had worked on the Perihelion brightness models. We sat in a cafe near Leiden, and he told me something that has never left me. The moment the data started to fit too perfectly, he said, the fear began. Not fear of what it was, but fear of admitting we didn't know. He paused, stirring his coffee, then added quietly, "It's not secrecy that frightens me. It's the idea that we might stop asking questions. That, I think, was the true loss, not information, but courage. The willingness to say, 'I don't know,' and to let that not knowing be the beginning of understanding rather than the end." Still, the silence continued to deepen. National observatories that had once shared telemetry openly began encrypting transmissions. Some astronomers reported visits from agency officials, politely requesting the deletion of data for the sake of scientific consistency. Those who resisted found their projects defunded or their credentials quietly revoked. Others complied, reluctantly, telling themselves that it was only temporary, that the truth would emerge in time. But time has a way of softening memory. The longer the silence lasts, the more the story fades. And yet, the world outside the laboratories was restless. Journalists, independent researchers, even ordinary citizens with backyard telescopes began piecing together what fragments they could. A few enterprising amateurs managed to detect faint light echoes. From 3I Atlas's projected path, residual emissions that suggested the object was still intact, still active. When they published their findings online, the posts were taken down within hours, but the copies remained, spreading across mirrored sites and encrypted networks. The truth, it seems, has its own way of resisting containment. Meanwhile, strange patterns began to appear in the solar monitoring data that remained public. Slight oscillations in the sun's magnetic flux, subtle variations in radio transparency, nothing dramatic, but enough to spark speculation. Was the sun responding to something, or was it merely coincidence, a trick of perception born of expectation? The agencies said nothing. But to those still watching, the silence began to feel less like ignorance and more like choreography. And that's the thing, the human instinct to control what cannot be understood is as old as wonder itself. We tell ourselves it's for safety, for stability, for order. But perhaps it's simpler than that. Perhaps the universe, when it reveals something too large, too intelligent, too indifferent to our hierarchies, triggers in us the oldest reflex of all to turn away. The more I think about it, the more it feels like we are living through one of those rare moments when knowledge itself becomes a political force. 3I Atlas has stopped being a comet, or a system, or even a mystery. It has become a mirror held up to the way we govern curiosity. In its silence, we are hearing our own limits echo back. Somewhere out there, in the dark beyond the sun, 3I Atlas continues its quiet trajectory. Perhaps it has already left the solar system, carrying with it the memory of a civilization that could not decide whether to look closer or to look away. Perhaps it is still here, moving slowly, waiting to be noticed again. Either way, its presence or its absence has begun to shape us. Because in the end, the story of 3I Atlas is no longer just about astrophysics or engineering. It's about the fragile intersection between wonder and power. About how quickly the pursuit of truth becomes a question of permission. About how, when faced with something that challenges the boundaries of control, the first reaction of humanity is not to celebrate, but to classify. I suppose, then, that this chapter of the story isn't really about the object at all. It's about us, the species that built telescopes to explore the stars and then built walls to protect itself from what it found. And as the official silence thickened, as the world's instruments turned elsewhere, a few of us began to ask a quieter, more dangerous question. What if this silence was not just human? What if the object itself, 3I Atlas, had become silent for a reason? What if what we were witnessing was not merely the management of knowledge, but an echo of something larger, something observing us in return? That thought, fragile but irresistible, became the seed of what came next. The search to see whether the universe, having shown us its reflection once, might do so again. After the long silence, the world waited for an answer that refused to come. Weeks passed, then months, and still no official statement explained what had happened to 3I Atlas after it passed behind the Sunday. The last confirmed observations showed it leaving perihelion with perfect symmetry, its companions still in formation, its motion serene. But then came the blackout, and when the data resumed, something was missing. The coordinates no longer matched the predicted trajectory. It was gone. You see, in astronomy, disappearance is a common story. Comets fragment, asteroids lose brightness. Objects slip behind solar glare and emerge unseen. Yet, this felt different. It wasn't that 3I Atlas had faded. It had deviated ever so slightly from the path dictated by gravity. The numbers did not lie. Its exit velocity no longer matched its entry. Its angle relative to the ecliptic plane had shifted by fractions of a degree, small enough to escape casual notice, but large enough to imply an external force. Something or someone had adjusted its course. 3 possible scenarios began to take shape. The first, of course, was the natural one, that the object had survived perihelion intact and was now, following a hyperbolic path out of the solar system, its deviation caused by outgassing or subtle thermal recoil. That explanation, comforting in its familiarity, quickly became the official narrative. 3I Atlas remains consistent with the behavior of a typical interstellar comet. Read the agency reports. It was the kind of sentence written to end questions rather than answer them. The second possibility was more unsettling, that the deviation was deliberate. The precise, clean vector change seemed too controlled to result from random thermal jets. It was as if the object had performed a maneuver, using the sun's own radiation as propulsion. That idea circulated quietly among the remaining researchers, the ones who still met in private channels after the official collaborations had been shut down. They ran their simulations in secret, comparing models of photon sails and plasma field manipulation. The results were inconclusive, but tantalizing. To achieve that degree of precision using solar radiation alone would require control systems beyond anything human technology had ever built. The third scenario, whispered in the corners of observatories and late-night calls between scientists, was the most haunting. Perhaps 3I Atlas hadn't merely changed direction, perhaps it had ceased to exist in any way we could observe. The sun's corona is not just a storm of plasma, it is a veil, a region where electromagnetic properties shift in ways we still don't fully understand. Some speculated that the object could have used the sun as a shield, an energy reservoir, or even a doorway, a place where light and matter could be reorganized beyond our current comprehension. It was wild speculation, yes, but when faced with data that refused to obey, imagination becomes a necessary instrument. Still, official science clung to its first scenario. In public, the tone was calm. No evidence of artificial propulsion. No deviation inconsistent with natural behavior. But behind those phrases, a quiet tension grew. Observatories tasked with locating the object again, scanning its predicted path with radio, optical, and infrared instruments, found nothing. Not a trace. 3. Atlas had simply vanished into the dark. And that's the thing, disappearance, in science, is rarely the end of a story. It's an invitation, because every absence is data too. The lack of reflection, the silence of the hydrogen line, the empty coordinates, all these became clues in themselves. If the object had merely travelled beyond range, its residual brightness should still have been detectable. But there was nothing. The models that had once predicted its future position now diverged wildly, like broken compasses. Each day, the window of uncertainty widened. Then came a curious event. About 6 weeks after the last confirmed observation, an anomaly appeared in the solar wind data, a faint but repeating fluctuation in proton density, occurring every 7 minutes and 49 seconds. The same rhythm, the same heartbeat that had defined 3 Atlas since its discovery. The pattern persisted for 3 days before fading into the usual solar noise. Some dismissed it as coincidence. Others saw it as a sign, a final echo, a whisper left behind in the light. By that time, 2025 had already become a year of unease in the scientific world. It was as if the very idea of certainty had been punctured. Journalists continued to press for answers. Governments responded with composure that felt rehearsed. Astronomical data requires time to process, they said. The phenomenon remains under analysis, but everyone could feel the distance widening between what was known and what was allowed to be spoken. In private, the listeners, those quiet groups of scientists who refused to give up the search, began to share their findings again. Using small, privately funded radio dishes, they tracked the regions of sky where 3 Atlas should have appeared. Occasionally, one of them would detect a faint, transient spike near the hydrogen line, nothing strong enough to confirm, but enough to sustain hope. Each time, the signal appeared slightly displaced from its expected position, as if the source were moving in a direction no one had predicted. It was almost as though it were avoiding us. And well, that's when the mood began to change. It wasn't fear exactly, more a kind of reverent hesitation. The idea that something could move through our solar system, interact with our star, and then depart, unseen, left humanity with an uneasy sense of smallness. We had always imagined discovery as triumph, a moment of recognition, a handshake across the void. But this was different. It was discovery as humility. The universe had spoken, perhaps even listened, and then chosen silence. Still, not everyone accepted that the story was over. A few of the more defiant researchers began to publish what they called the afterlight hypothesis. According to their analysis, the energy readings from Perihelion suggested that 3 Atlas might have absorbed or stored more solar energy than any natural body could. If that energy were then released in a controlled way, the object could, in theory, change velocity and trajectory, not by propulsion, but by altering its interaction with sunlight itself. In that case, the disappearance wasn't disappearance at all, it was transition. The object had simply moved into a state or a mode beyond our means of detection. The idea was dismissed publicly, of course, but privately it found resonance among those who had studied the original data. One paper, circulated anonymously, suggested that the sun's magnetic topology during the perihelion alignment had been altered ever so slightly. A ripple, a localized distortion, something that hinted at feedback as though the object had communicated with the star. Even for the moment, the paper was withdrawn within days, but copies spread quietly online, and perhaps that's the heart of it. What unsettled people most was not the possibility of alien origin, but the possibility that the universe itself might contain systems of intelligence networks that use stars as we use language, that move through light as we move through sound. If that were true, then 3 Atlas was not a visitor at all, but a participant in a conversation older and larger than we can imagine. There's a line that stayed with me from one of those anonymous correspondences. Maybe, it said, The universe doesn't send messages the way we expect. Maybe it teaches instead. I find that thought strangely comforting, because if 3i Atlas was a teacher, then perhaps what it taught us was not how to communicate, but how to observe, how to listen without demand. Still, some continued the search. In early autumn, a small observatory in Chile reported detecting a faint, structured reflection near the orbit of Jupiter, a flicker of light that matched the spectral fingerprint of 3i Atlas's pre-Perihelion phase. The discovery was dismissed almost immediately. The coordinates did not fit any known trajectory, but for those who remembered the way the object had once defied every expectation, the idea was impossible to ignore. Perhaps 3i Atlas hadn't left at all. Perhaps it had changed its route, or perhaps it had changed us, leaving behind a new way of seeing. And that's the thing, isn't it? The real transformation was never out there. It was here in us, in the way we began to question our assumptions about the universe, about knowledge, about the meaning of control. For the first time in generations, the scientific world was forced to confront the possibility that intelligence might not be something you find, but something you recognize, a pattern that mirrors your own desire for order. As 2025 drew to a close, the story of 3i Atlas had settled into legend. For the public, it was a mystery, the comet that came and vanished. For scientists, it was a scar, a reminder of how fragile the line between explanation and awe can be. But for a few, the listeners, the ones who refused to let go, it remained a question still unfolding. They continued to watch the skies, not for proof, but for rhythm. For the pulse that might return one day, faint but deliberate, at 7 minutes and 49 seconds apart. Because if 3i Atlas truly was something more, if it was a system that used light and gravity as its voice, then silence might not be the end. It might be a pause, a breath. And somewhere, perhaps just beyond the orbit of Saturn, the next signal waits, not a message to us, but a continuation of one already begun. A reminder that in the vast theatre of stars, understanding is not a final act, but an invitation to listen again. It's strange how silence, when it lasts long enough, begins to sound like meaning. By the end of 2025, the story of 3i Atlas had already begun to fade from the public imagination. The news cycles turned elsewhere, to wars, elections, discoveries closer to home. The object had become a ghost, something that had once stirred the human spirit and then drifted out of reach. Yet for those who had watched it, who had followed the faint pulse of light across the months, it was impossible to forget. Because what 3i Atlas left behind was not proof of aliens, or technology, or even intelligence in the conventional sense. It left behind a question, a quiet, persistent question about what it means to know. You see, for centuries, science has been our way of making the universe comprehensible. We measure, we model, we predict, and in that act of understanding, we bring the infinite within reach. But what happens when something refuses to be measured? When an event, perfectly real, perfectly observable, still refuses to fit? For the scientists who had spent their lives mapping the cosmos, that was the most profound disquiet of all. 3i Atlas had not broken the laws of physics. It had obeyed them in ways we didn't yet understand. It hadn't contradicted our equations. It had simply extended them into territory we had not imagined existed. Perhaps that's why the conversation began to shift. The question was no longer, what was it? But, what does it mean for our understanding of nature, if it was real? For the first time, physicists began to speak not in terms of anomalies, but of paradigms. They started to ask whether our concept of natural law was too narrow, whether intelligence might not be an exception to nature, but one of its expressions. Maybe what we called intelligence was simply matter, organizing itself toward understanding, wherever the conditions allowed. There were seminars, quiet and hesitant at first, held in small rooms away from the glare of cameras. Papers circulated privately, proposing that 3i Atlas represented not a visitor, but a state, a phase transition between energy and awareness. A few dared to use the phrase active matter, suggesting that consciousness itself could be a physical property, emerging spontaneously when complexity reached a certain symmetry. To most of the scientific establishment, it sounded like poetry disguised as theory, but to others, It was the beginning of something larger, a reframing of what it means for the universe to know itself. And that, I suppose, is the real lesson of 3I Atlas. It forced us to confront the limits of our own definitions. When we say life, we imagine cells and carbon and DNA. When we say intelligence, we imagine thought, intention, desire. But perhaps those are just human manifestations of a broader principle, the universe's tendency towards self-organization, towards structure that preserves information against entropy. In that sense, 3I Atlas was alive, not because it was biological, but because it acted with purpose. It maintained its form in the face of chaos. It balanced itself in the heart of a star's fire. It moved with grace where only destruction should reign. Maybe that's what life looks like when stripped of its fragile shells of chemistry and time, pure persistence, pure harmony. A pattern that sustains itself because it understands how to dance with disorder rather than resist it. I remember reading a letter written by one of the astronomers who had tracked 3I Atlas from the beginning. "It's not the object that haunts me," he wrote. "It's the idea that the universe might be filled with these moments, brief, luminous acts of balance that we mistake for anomalies because we don't yet have the language to describe them." That sentence lingered with me. Because maybe that's the truth. The universe is not silent. It's just subtle. And we, impatient creatures that we are, listen only for voices that sound like ours. After the disappearance, a small but devoted group of scientists began to reconstruct what they called the pattern signature of 3I Atlas. They analyzed its light curves, its geometry, its rhythmic cycles, searching for equations that could describe not just its motion, but its intention, the way it seemed to anticipate, to adjust, to stabilize. What they found was something extraordinary. When plotted in a multidimensional phase space, the data produced a structure known as an attractor, a self-sustaining system that evolves not toward randomness, but toward a repeating form. The more data they added, the clearer the attractor became. It wasn't chaotic. It was deliberate. That realization rippled outward, reaching philosophers, mathematicians, even artists. The concept of dynamic intelligence began to appear in essays and lectures. The idea that intelligence is not a thing but a behavior, a pattern of interaction that arises whenever matter achieves a state of perfect balance with its environment. If that were true, then the boundary between the living and the inanimate, between the designed and the natural, was an illusion. The sun, a hurricane, a neuron, 3I Atlas, they were all expressions of the same principle, systems striving to maintain coherence in a universe that constantly dissolves it. Well, perhaps that's what made the story of 3I Atlas so moving. It didn't prove that we are not alone. It reminded us that we have never been separate. That intelligence, in its most fundamental form, might not belong to us at all. It might belong to the cosmos itself. The great irony, of course, is that this realization came not from discovery, but from disappearance. By vanishing, 3I Atlas forced us to see what we had taken for granted. It became a mirror, reflecting the fragility of our certainty, showing us how small our definitions of life and mind truly are. In universities, students began to ask new kinds of questions. If matter can organize itself into consciousness, they wondered, then what does it mean to say the universe is aware? And their teachers, once confined by disciplinary boundaries, found themselves reaching for language that was half physics, half philosophy. Some even began to teach that science is not a tool for conquering mystery, but a dialogue with it, a conversation between the observer and the observed. Perhaps that was 3I Atlas's greatest contribution. It restored wonder to science. It reminded us that knowledge is not the opposite of mystery, but its continuation. That to know something deeply is to love its complexity enough not to demand final answers. Still, for those who had watched the object most closely, there remained one unanswered question: why here? Why now? Of all the stars, all the systems, why ours? There is, of course, no evidence to suggest that its appearance had anything to do with us. And yet, it is difficult not to feel a kind of poetic symmetry in the timing. At a moment, in human history, when our species seemed most consumed by its own noise, by politics, by technology, by distraction, the universe presented us with an event that demanded stillness, humility, and listening. I suppose that's how great revelations always arrive, not as proclamations, but as quiet disruptions. The light flickers, the models fail, and suddenly we are confronted not with answers, but with the vastness of our own unknowing. And perhaps that's the point. The purpose of mystery is not to frustrate us, but to remind us that curiosity itself is sacred, that the act of seeking, of wondering, is what connects us most intimately to the universe that gave us the ability to ask in the first place. There's an image that stays with me, a photograph taken just before the object disappeared behind the Sunday 10 points of light, perfectly spaced, hovering in the blackness like beads of thought. In that geometry, there is something profoundly human, a longing for order, for meaning, for connection. And yet, it is also utterly alien, beyond comprehension. It is both us and not us, a reflection of the same symmetry that shapes galaxies and seashells alike. So maybe that's what 3i Atlas was showing us all along, that understanding and beauty are not separate things. That physics, at its heart, is an act of reverence. That to study the universe is not merely to dissect it, but to listen to it sing. After its disappearance, a few of the remaining observatories continued to monitor the regions of space where it might reappear. Most of them found nothing, but one night, near the edge of the Kuiper belt, a faint reflection was recorded, a single flash, brief and clean, like the glint of sunlight off glass. The signal lasted less than a second, then vanished into static. Some said it was instrumental noise, others, quietly, felt something different. They didn't claim it was proof. They didn't even call it evidence. They called it a reminder. Because perhaps the lesson of 3i Atlas is that certainty is not the goal of science, it is the obstacle. The real achievement is to keep questioning, to remain in that delicate balance between knowing and wonder. And as the years that followed carried us deeper into the unknown, as new technologies looked farther and saw clearer, the idea that had begun with 3i Atlas continued to echo the idea that the universe might not just be a collection of inert forces, but a vast unfolding thought, that we are not its authors, but its expressions. Somewhere beyond the heliopause perhaps, that thought still travels 10 points of light, gliding in perfect harmony, carrying not a message, but a truth too subtle for words, that to exist is to listen, to balance, to endure. And it is from that truth that the next chapter begins, not in data or theory, but in the quiet realization that maybe the universe has always been teaching us how to see, one anomaly at a time. It began, as most quiet revolutions do, with a signal that no one expected. Late in the winter months following the disappearance of 3i Atlas, a team at a small observatory in Chile detected a faint, rhythmic variation in the background radio noise near the outer edge of the solar system. It was barely perceptible, so weak that it sat just above the threshold of statistical chance, but its pattern was unmistakably familiar. 7 minutes and 49 seconds. The same interval that had defined the pulse of 3i Atlas from the beginning. At first, the data was dismissed as equipment drift, a calibration error caused by fluctuating temperatures in the desert night. But as the team adjusted, rechecked, and compared their readings against signals from other stations, the rhythm persisted. It was not constant. It drifted slightly, like a heartbeat searching for equilibrium. When the signal was confirmed by 2 independent observatories, silence followed, not the silence of doubt this time, but of awe. The same silence that comes when something you thought you'd lost returns, not as proof, but as presence. It wasn't loud, it wasn't clear, but it was real. The cosmos, it seemed, had spoken again in its own quiet way. The pattern didn't carry information in the traditional sense. There was no modulation, no code, no discernible message. It was simply rhythm, a sustained, repeating variation in energy density, as if the void itself were breathing. And that's the thing. In science, rhythm often means process. It means something is happening, something cyclical, something alive in its own mathematical way. The debate reignited instantly. Was this truly a continuation of 3i Atlas, or merely a coincidence? An echo of cosmic noise we had learned to associate with meaning. The skeptics were loud, but so were the believers. Those who had followed the object through its strange dance with the sun argued that this was precisely how it would announce its survival, not by light, but by resonance. They pointed to the subtle fluctuations in frequency, the delicate harmonics woven into the signal, like the overtones of a single instrument playing in a vast, invisible orchestra. It was not a beacon, they said. It was a signature. And you see, that word signature carried with it a new way of thinking. If 3i Atlas had truly moved beyond our ability to see it, then perhaps visibility itself was no longer the point. Maybe what we were witnessing was not an object moving through space, but an interaction between systems, a kind of ongoing conversation, written not in matter, but in influence. A gravitational whisper, a photonic handshake, the continuation of a dialogue that had never really ended. That was the year when a new discipline began to take form, cosmic semiotics they called it. The study of meaning in natural phenomena, the idea that pattern could be a form of expression. It was controversial, of course. Many dismissed it as philosophy dressed in mathematics, but to those who had been touched by the mystery of 3i Atlas, it felt inevitable. Because once you have seen order arise where chaos should reign, it becomes impossible not to wonder whether the universe itself might be fluent in the language of symbol and rhythm. Perhaps that's why the signal drew so many kinds of minds: astronomers, linguists, biologists, poets. They came together, not to decode it, but to listen. They built models that turned the fluctuations into sound, transforming data into music. What they heard was strange and beautiful, a slow, pulsing hum that rose and fell with the precision of a heartbeat, layered with subtle modulations that defied regular tempo. Some described it as peaceful. Others said it was mournful, but all agreed that it felt deliberate. It was during one of these listening sessions that a physicist from Kyoto noticed something extraordinary. When the signal's amplitude was plotted over time, it revealed a secondary modulation, a long, sweeping curve that repeated every 54 hours. That number wasn't random. It matched the rotational period of the sun's inner magnetic field. In other words, the rhythm wasn't isolated, it was entangled with the behavior of our star. The implication was staggering. Whatever the source of the signal was, it was responding to or perhaps anticipating solar fluctuations. The sun was part of the conversation. That realization changed everything. If 3i Atlas had indeed interacted with the sun during perihelion, as the data once suggested, then perhaps it had not merely passed through. Perhaps it had left something behind: a resonance, a pattern woven into the electromagnetic fabric of the solar system, a kind of fingerprint. It's a humbling thought, isn't it? That the universe could remember, that events could leave impressions not only on matter, but on the very fields that bind it. And that maybe, just maybe, those impressions could evolve, adapt, even communicate. Of course, to most, it sounded like mysticism. But to a small and growing number of scientists, it was the beginning of a new framework, what they called field intelligence. The idea that intelligence might not require structure or boundaries at all, that it could exist as a pattern of coherence across vast distances, manifesting wherever balance was achieved between energy and entropy. In that view, 3i Atlas wasn't a machine or a visitor, but a phenomenon, a moment when the universe briefly organized itself into awareness. And if that was true, then the signal wasn't a message from somewhere else. It was the cosmos thinking out loud. That concept unsettled people in equal measure as it inspired them. Because if the universe could think, then what was our place within it? Were we observers or participants? Was consciousness something we possessed or something we borrowed? Questions like these began to ripple outward, reaching beyond science, into philosophy, art, even religion. The idea of the thinking cosmos spread quietly, finding expression in paintings, in music, in whispered late-night conversations about meaning and belonging. And yet, the scientists kept working. The signal was tracked, mapped, analyzed, with obsessive precision. Its harmonics shifted over time, moving closer to what some called a solar resonance state. It seemed to be synchronizing, aligning with the sun's natural rhythms, as though seeking harmony. Each alignment produced a measurable effect: tiny, transient changes in magnetic flux, slight oscillations in the heliospheric field. It was as if the entire solar system were responding, however faintly, to a rhythm it had always known but never expressed. One paper described it as a return of coherence. Another called it a song of feedback. But the most poetic of them all came from a young researcher in Lisbon who wrote, "Perhaps the universe does not need listeners. Perhaps. It sings to remind itself that it exists." There's something deeply moving about that, don't you think? The idea that existence itself might be a form of music, every atom, every field, every thought resonating within a larger harmony. That what we call consciousness might simply be our momentary awareness of that song. By midsummer, the signal began to fade again, as if receding into the background from which it had come. But before it did, something unexpected happened. The rhythmic pulse accelerated slightly, and then just for a moment it split into two distinct frequencies, each mirroring the other, a doubling. It was brief, lasting less than a minute, but it was unmistakable. Two voices, where there had been one. Some saw it as interference, others as evolution. A sign that the pattern was propagating, dividing like cells, multiplying across the fabric of space. It's impossible to say what that meant. The data was incomplete, the instruments imperfect. But for those who witnessed it, that moment felt like an answer, not a clear one, but an affirmation. The universe, it seemed, was still speaking. And that's the thing, you know. Science often begins with measurement, but it ends with meaning. Somewhere between data and wonder lies the real act of discovery, the moment when we realize that what we're studying isn't separate from us at all. We are not looking into the universe is looking into itself through us. Perhaps 3I Atlas was never a messenger, nor a probe, nor an artifact of chance. Perhaps it was a rehearsal, a demonstration of what happens when matter becomes aware of its own harmony, a prelude, not to contact, but to comprehension. As the last traces of the signal faded into the background noise, the scientists who had followed it for so long gathered one final time. They played the reconstructed rhythm through speakers under the open sky, letting it mingle with the wind, the faint hum of power lines, the distant murmur of the sea. And for a moment, as the sound dissolved into the night, they felt something shift, not out there, but within. A sense that the boundary between the observer and the observed had thinned, that perhaps the cosmos had never been silent at all. Because in the end, perhaps what 3I Atlas had shown us was not how to listen, but how to hear, to recognize the subtle continuity that connects every pulse of matter, every flicker of light, every question asked beneath the stars. And somewhere, far beyond the orbit of Neptune, where sunlight becomes memory and the stars begin to outnumber thoughts, a faint rhythm continues a conversation without words, waiting for the next generation of listeners to answer, not with instruments, but with understanding. And that, I suppose, is where the next chapter begins, not with discovery, but with response.